Requirements for this section include understanding how to start a container, and then basic TCP/IP networking concepts such as subnets and IPs and ports and firewalls. You don't have to know all that, but it'll definitely make it a lot easier for you to understand this section, which is focused on conceptual stuff before we actually get into a bunch of the command line stuff in the next lecture. So I just want to remind you about the -P option on your container run commands, which exposes the port on your machine. But there's actually a lot more going on in the background of Docker networking that we'll talk about. Docker has this concept of batteries included but removable, which basically means that the defaults are pretty easy and common to work with, but that you can change a lot of the options under the hood. And we'll quickly check out in this lecture the container port command that gives you a quick output of what ports are open for that container on your network. And then we're going to break down some of the concepts of Docker networking and virtual networks and how packets flow around the network. And we'll finish up with a network diagram showing how containers talk amongst each other and how that's different from the -P of exposing them onto the physical network. So when you actually start a container, you're really in the background connecting to a particular Docker network. And by default, that is the bridge network, as we'll check out in a minute. And then each one of those networks that you would connect to actually route out through a NAT firewall, which is actually the Docker daemon configuring the host IP address on its default interface so that your containers can get out to the internet or to the rest of your network and then get back. But we don't actually need to use the -P when we have specific containers wanting to talk to each other inside our host. So for example, if you had an application that had a SQL server and a PHP Apache container, those two containers should be on the same network and they're able to talk to each other without actually opening their ports up to the rest of your physical network. And if you had another application that was unrelated, that let's say was using Mongo and Node.js, you could create a network for that so that they could talk with each other without using the -P to expose them to the network, but they couldn't actually talk to the other network where you might have an unrelated app running. But the thing is that just about all those settings I described are actually changeable. And this brings up a good saying that Docker likes to use that is batteries included but removable. And you'll see that throughout this course that a lot of times there are defaults that just work out of the box. You don't even have to specify them. You just notice that things are configured in a sort of standard way, but a lot of these options are configurable either at runtime or even changeable after the fact. And we'll see some of that take place here when we play around with the networks. Some of the things that you can actually change would be creating multiple virtual networks, maybe one per app, or different ones based on different security requirements. And you can actually, just like in the physical world, have two physical NICs on a real computer. You can actually have two virtual networks connected to one container, or you can actually have the container talk to no networks. And you can skip any of the virtual network configuration that comes out of the box and actually use --net equals host. And you'll lose some of the containerization benefits, but in some cases, it might be required. And later on, we're actually going to get into Docker network drivers. And there's this whole plugin ecosystem around Docker that extends the capabilities of Docker to a lot of third-party tools. But in this case, we're going to look at a couple of different Docker network drivers and how they might change up our networking and give us new abilities. And this is really just scratching the surface. There's actually networking concepts throughout this course where we'll be talking about more advanced topics of multi-host private networking and concepts like sub-interfaces and so on. But for now, let's dive into some command line stuff. As a quick review, let's look at the -P of our container run command. So Docker container run. If you remember when we first ran a container, we used the -P to expose port 80 of our Nginx. And that took the left side, which is the host port, and forwards traffic from that port into the port 80 of the container. And if we did a Docker container port web host, it actually shows us in a nice, easy format which ports are forwarding traffic to that container from the host into the container itself. But we haven't talked about the IP address of the container. And so you might just assume that the container is using the same IP as the host. But by default, that's not true. And we can easily get the Docker IP of that container by inspecting it. And we're going to use the format command, or option really, which you'll notice actually has a pretty specific format for how to filter incoming stuff. Now you can always use the grep command, which we used earlier, to filter out your text output. But the format, the -- format, it's actually a little cleaner and consistent. So we do 2 curly brackets. And then once we get used to knowing the format of the config file, we know that network settings IP address is the actual node of that JSON output that we want to look at, and then web host. Oops, that means I didn't spell it right. IPADD. And that's not what I expected if I was going to use the IP of my host, because I know my Mac's on my local network, and if I do an ifconfig on my Mac, I just know that the IP addresses on my home network are a 192.168 subnet. So that's interesting that they're not the same network. So why is that? Let's see if it'll make more sense if I draw it out. So if my host operating system is connected to my network, so this is my network, physical network, and then this is the Ethernet interface on my host machine. In my case, it's my Mac. There's a little firewall in there that does several things. And it blocks all incoming traffic coming in from the network so that everything is blocked by default. So I would call it a firewall. And any traffic that's coming out from my containers is going to be natted by default. So it's acting like a pretty common edge firewall on a network. But there's this concept of the virtual networks, and by default, you'll see a network called Bridge or Docker 0. And when you start a new container, we'll call it C1, that container is attached to that network, that virtual network, and that virtual network is automatically attached to your Ethernet interface on your host so that it can get out. Now in our case, when we just launched that Nginx, we gave it a -P 8080. And that told it over here to open up port 80 on my Ethernet interface on my Mac and forward anything coming into port 80 through that virtual network to port 80 in that container. Now by default, when I create a second container, it's put on that same bridge network. And those two containers can talk freely back and forth on their exposed ports. But unless I specify the -P, no traffic coming into my internal networks here is going to get to my containers. Now I can actually create more virtual networks and call them what I want. So I'm going to call this one net my app, let's say. And let's say I connect 2 containers here. I got a MySQL, and then I got an Apache. And on MySQL, I didn't open up any ports. I never specified a -P. But on the Apache one, I gave it a -P of 8080:80. That would mean over here on the right at my Ethernet interface on my host, it's going to start listening on port 8080. And as soon as traffic comes in to my host on port 8080, it's going to route it through down to this new virtual network I created and into that Apache server on port 80. But inside this virtual network, the Apache server is free to talk to the MySQL server over its listening port. So when you think about virtual networks in Docker and where containers belong, think about how you would put different containers in proximity to each other because they're related in their application. As you can see, these two examples, if I had container 1 and container 2 up top running something different, if they're not going to be talking to the services in this network down below, then it would make sense to keep them on separate virtual networks. And if they ever had to talk to each other, they would have to go through their published ports all the way out and back in. And as a reminder, on any interface on your host, you can't listen on more than one port for multiple containers. So you can't have two containers listening on the port 80 at the host level. Okay, only one can do that. And if you tried to start another container, it would actually error out and say that there's already something else on that port. And that's not a Docker limitation, that's just a limitation of how IP networking typically works. So just a quick recap on this section. We actually spent a lot of time on the concepts of Docker networking, including the exposing of ports on your host to the physical network using the -P, and the idea of Docker focusing on sane defaults, where they call it batteries included but removable, and how for local dev and testing, you probably can just get by with the defaults, but everything is changeable. And then we learned about the container port command, which is a quick way to look at the ports exposed for your particular containers. And then we broke down the packets moving around virtual networks and how those relate to other virtual networks and how they get in and out of your Docker machine. So these are all really good concepts to understand as we jump into the actual CLI stuff in the next lecture.